work on leetcode problem 1095, find in mountain array. I think this problem is not so hard, and it's basically a binary search. But the issue is you need to do the binary search multiple times. So I think if for an interview, if they want to ask you some hard question, and this is one of the choices, so I suggest everyone will be able to solve questions like this. So let's see what this question is about. So we're given an array. This array is defined as a mountain array. And here is the definition. And this array must have length larger or equal to 3. And then there is a peak value inside this array. So before that value, every item is less than the next element. And after this peak, every element is less than the previous element. So it's just like a mountain, so we call that mountain array. And we are given this mountain array, and we will return an index. So this task is to find the element with the value equal to a target. So we will return that value's index, and we cannot do a loop inside mountain array, and because it has some limitation for 100 calls. So and if there are multiple target value, we'll return the one with the smallest index. So the way to do that is we can do multiple binary search inside this mountain array. We first find where the peak is. So the first step is to find peak position, P. And the second one is to search from index 0 to P if there is a value equal to target, right? If not, then we search from index P to the length -1 and for target. Yeah. So in step 2, if we found the target, we will return, and otherwise we go to step 3, and if we cannot find target in step 3, we'll just return -1. So this is the algorithm, and let's see how to implement it. So we will implement two functions, I think. One is to find the peak. So this is get peak with an input mountain array as an input. It's called the MR, mountain array. Okay, then we also need one function to find the index, get index, right? So this function is to search from left to right, try to find the target value inside something. Okay, and we also need to write a function to check the up. This means given the mountain array and one index, we will see whether the next index is greater than the current index value. Okay, we'll implement these three functions. Then things will be quite easy after we have these three functions. So suppose we have already got those three functions, we say peak is just get peak MR. Then we try to get index for element between 0 and P to search for target. And if U, then we return Otherwise, we search for the target in the second half, then we return U. Okay, this is the algorithm. Then we implement get peak first. So this is binary search because at the first half we have the property that the next element is greater than the current one. So we can use this property to do the binary search. So L equals 0. The initial value for R is MR length minus 1. Then for L less than R, we can do the binary search. So we define the middle value. Then if app it means the left of this binary search should be at least at M, right? So L equals M. No, if up, it means the left of this. Remember that for the peak value, its up is false, right? So this means R equals M, right? Otherwise, L should be equal to M plus 1. Let me see again. So if we have up, it means we're in this segment, right? So and otherwise we will in this segment, so that if we found up, we'll do something for L equals L equals M minus 1, then R equals like this, right? So we have L, it should be at least M. This is M plus 1, I think, because we already have M, and for R it's M, right? Then we return L at the end, right? Yeah. Then for get index, we have already have left and R. Oh, we haven't implement up function, right? So if U is equal to MR length minus 1, we just return false. Otherwise, we return MR get U plus 1 is greater than MR get U. Okay, this is up function. Then we implement this get index. So we already have L and R, so we just L plus the R, we do the binary search. Then we try to find the value, MR get at M. So if this value is let's see here. We want to find the value that is the first occurrence in this index, so that the right side is here. All the right side have the property that are greater or equal to value. So if value less than target, the minimum of L should be m plus 1, and otherwise R can be m, and the item we want to return is R, right? I think here is also we need R. Yeah, I think we're done. Let's see if this works. Get peak. Oh, we can change it to MR. This is equal. We have a wrong answer. Let's see what's happening here. So this one is passed, and this one is not. Target equals 3, 0, 1, 2. So we should return -1, right? However, we return something here. Yeah, I think we need to check one more time. If mr get r equals target, we return r. Otherwise, we will return -1. Yeah, this will work. Let's submit. Target is 1. C. Let's first see if the peak value we find is correct. Okay, for this test case, the peak value is 1. It seems correct. So this is the position for the peak. So I think there's something wrong with the binary search in this case. Let's look more closely for the binary search part. So the input should be 0 to P, so it's 0 to 1, right? If L is 0 and R is 1, then this is 0, right? And value will be equal to target. So R will be set to 0. Then this will actually return R. Let's see if, oh, right. We only need to check for minus, right? So delete this line and submit. Target is 2. We are searching between P and length -1. And if in this case R is length -1, it's 2, right? L is 1. Then L plus 1 divided by 2 is 1 again. Then L equals m plus 1. and R is also. Oh, I think the issue is we need to write another get index for the second half, right? Because they are having different compare function here. The second half should be like this, okay? So yeah, I think this will work. Let's try. Okay, we pass. Yeah, this issue is solved. And thank you very much for watching, and see you next time.